Today, we are bringing the focus to how climate change is impacting the landscape of Indian cities.
Ashwin Rode, our Director of Scientific Research at the Energy Policy Institute at University of Chicago, is working towards understanding exactly this problem.
Chairing the conversation today and joining us is Ms. Dr. Debolina Kundu. She is the Director for National Institute of Urban Affairs, a leading think tank under the Ministry of Housing and Urban Affairs, Government of India.
I'm going to describe some ongoing work on the urban mortality consequences of rainfall and sea level rise. And we find approximately that a half-meter sea level rise would increase the rainfall-driven excess mortality by around 50% in the absence of adaptation and re-engineering measures to prevent this.
So my question is, how would you transfer this methodology to other coastal metros like Kolkata or, for that matter, Chennai?
So the combination of rainfall and tide patterns would be relevant to coastal cities like Chennai, Kolkata also. In fact, the hydrologists study this phenomenon. They have a name for it. It's called tidal jacking. And studying those in other Indian cities and global cities is definitely possible for the coastal cities.
How would you extend this framework to incorporate climate model projections of monsoon variability, extreme event frequency, and compound hazards like concurrent heat waves and flooding to inform long-term resilience of the
Clouds and rainfall are just a harder problem to solve, as I understand from my climate scientist collaborators. So they're getting there, but have not yet reached that same level of daily extremes as with temperature. But as those advances occur, we should definitely feed them back into our research and do those projections.
How can we generate city-level exposure-specific mortality and morbidity data?
Yes, all-cause mortality data is the best we could do. It has certain advantages, it also has certain disadvantages. We should also be looking not just at the extremes of people dying, but also morbidity, which is also likely to respond to heat or rainfall, and there could be significant productivity gains from avoiding this if we can avoid this morbidity.
What low-cost, high-impact adaptation measures, as for example, localized pumping stations, community-led drainage maintenance, early warning systems, would you prioritize in resource costs?
Yes, I think the next steps should be to try to understand which of these is especially effective, cost-effective, right? Informational interventions seem like early warning systems. They seem very promising based on other work in like the agricultural setting, different from the urban setting, but given how low cost they are, they could go a long way. This may even include like informational campaigns to keep children away from puddles and things like that, since we're finding such huge impacts on children under 5.